Hello guys, welcome to my YouTube channel Code and Canvas. In this video, we are going to learn about observer design pattern. So let's try to build a weather monitoring system. This system tracks current weather conditions, which includes temperature, humidity, and biometric pressure. It also provides three display elements, which displays current conditions, weather statistics, and simple forecast on them. We want to build an API so that others can also write their own custom displays. Apart from the displays we provide, anybody can write their own display as well. So in this scenario, we have mostly three players: a weather station, which can be set as a physical device that can acquire actual weather data object that tracks the data coming from the station and updates the display, and a display which shows the current weather conditions. As you can see in the diagram, we might have three sensors. They give updates to weather station, which can be said as a physical device or something, and then the data is pulled by our weather data object, and on change of any data, the display gets updated. So the first thought that comes to our mind to implement this weather data object will be something like this. So we will have a get temperature, get humidity, get pressure. These getters method on different weather statistics, and we have a method called measurements change, which gets called whenever we get any update on these temperature, humidity, or pressure. So our condition is display must be updated whenever this measurement change method is called, and any measurement has changed, our display must get updated. And our system should be expandable as well, right? So let's look into our first implementation, which will look something like this. So we get the temperature, we get humidity, and we get pressure using these getter methods, and then we update all the three displays that we have in our system. So we pass all the temperature, humidity and pressure as the parameter in all the three displays. But here we are coding to concrete implementations, right? For example, let's say tomorrow we want to build a new display. We have to come here and add the display manually, right? We have to make code changes in this particular class, and again the testing and everything will be required for the same code, right? So this is not very much expandable as well as testable, right? It's not easy to test and expand. Also, this gets complicated when the data is used. Right now we only have three entities. Let's say tomorrow we have lots of data, different types of data. Then we have to pass it all the three displays on all the displays that we have, right? So this will get complicated with time. But as we can see, at least we have a common interface which we use to talk to all the three displays. For example, all the three displays except the temperature, humidity, and pressure values. So now let's say how observer pattern can solve this issue. So observer pattern works like a publisher and subscriber. In this, there is a subject object which manages a data. For example, in our case, this weather data object, it manages some data, right? It manages this temperature, humidity, and pressure, and on change of any of these, it updates the display, right? So similarly, the subject will manage some data, and when the data in the subject will change, all the observers will be notified. So whoever is subscribed to this particular change, they will get notified. So let's look into the definition of observer pattern. The observer pattern defines a one-to-many relationship between a set of objects. When the state of one object changes, all the dependents are notified. So the same thing is happening here, right? We have an object which has a temperature, humidity, and pressure, and on any change on this object, we notify our displays. Same thing will happen in the observer pattern, but they will be interdependent of each other. So let's look into the diagram of observer pattern. So we have a subject interface which have basic methods to register an observer, to remove an observer, and to notify all the observers in case of any data changes. Similarly, we have an interface for all our observers as well, which has an update method. So this can accept a param for the data as well, but we'll look into this at later point of time. So apart from this interface, we have our concrete subject as well as concrete observer. So concrete subject will narrate from this implement this subject interface and will override all these methods, and it will have its own getter setter methods as well for different states and other purposes as well. Similarly, concrete observer will implement from this observer interface, and it will have its own methods as well for different purposes, and it has an object of this subject as well, so that it can use it to register himself or remove it remove himself from the observers list. So concrete subjects, they always implement the subject interface and they have their own methods. Similarly, concrete observers can be any class that implements this observer interface. It can be any class, and they register with the concrete subjects to receive updates. So that is why they have an object of the concrete subject as well. So in this pattern, the subject the only thing that subject knows about is the observer that it implements is an observer interface. So because subject needs to keep track of all the observers so that it can notify them whenever any change is happening, it only needs to know that the observer has implemented this observer interface. So by knowing, it knows it can, whenever any change happens, it can call its update method or whatever method you define here, it can call that method to notify the observers. So now here we can add new observers anytime, right? So because we have a list of observers here, and whenever a new observer wants to subscribe to this data, they can just implement this observer interface, and they can use the subject object to register themselves for that data change or to subscribe to that data change. So it will just get added to the list, and whenever the subject will notify the observers, that new observer will also get notified automatically. We don't need any code changes in the subject or anywhere else or in any other observers as well. So this is more flexible now. We will see a demo on this actually. We can use subjects and observers independently of each other. Now they are independent, and changes to any subject or observer will not affect each other because they are now not depending on each other implementation, right? It's not hard coded like this, like we have done here. So let's look into the class diagram on our weather data object. So we have an observable interface which have a register observer, remove observer, and notify observer methods. Our weather data will implement this interface and will have other methods as well for getter, setter, and for other purposes as well. So similarly, all our displays like current condition display, statistic display, forecast display, or any other third-party display that other clients wants to create on their own, they implement the observer interface to tell the tell our subject that whenever a change will come, our subject, which is weather data, will just have to call this update method on all the observers which are subscribed to it, and they might have another interface for displaying the value. So we can have another interface for displaying different displays on it. So they all have this they all implement this display interface as well. So they have overridden all the two methods from both the interfaces, update as well as display. So update takes care of any change that is happening in weather data, and display takes care of anything that is going to be displayed on the screen. So let's look into the implementation. So here is our subject interface. We are passing an observer here to register or remove the observer from the list, and we have an observer interface as well. So in this, we are still keeping all this float, temperature, humidity, and pressure variables as params. We have a display interface as well that takes care of the display. Now our weather data, which is a subject, it will implement the subject interface. It will have an array of observers which it needs to notify. It has all the variables related to the weather data. So initially the array is initialized as an empty array, and whenever a observer registers themselves, they pass their own object into this register observer, and we add it to the list. Similarly, while removing the observer, observer can call this method to remove themselves from the list. We just check like if the observer is present in the list, we remove it from it. While notifying, we just go through the list and call the update method on each observer. So we don't have to worry about adding new observers. So if any new observer comes tomorrow, they will just call this method to get added in the list, and whenever the notify observer will be called, the new observer will be called automatically. We don't need any code changes here, right? So whenever the measurement change is called. Whenever some data is changed, it will just notify all the observers. So we have a set measurement here as well, so that our weather station, which is a physical device, can call this method, for example, and update the new temperature, humidity, and pressure, and we call measurement change method here, which will again notify all the observers. So our display, all the three displays will have similar code examples. I have taken only one of them. For example, our current condition display, it will implement both the observer as well as display element interface. So it will override both update as well as display method. So display will take care of what needs to be displayed on the screen, and update will just update the data on its side. For example, we get temperature, humidity, and pressure as well, right? So we are updating temperature and humidity, which is required for this display, and we just call display to update the screen, the data that is displayed on the screen. Now you can see here our display, it requires only temperature and humidity, but because of the interface and the way interface is defined and the way our subject is passing data to our observers, we are passing all the values, temperature, humidity, and pressure. So imagine if there are like 50 data fields. So even if our observer requires only some of the data, we are passing all of it to the observer, right? Because we are using a push mechanism. So here observers are getting too much from what they actually require. So if in the future more state is added to the subject, we have to go to every update method, right? So let's say more state is added, instead of pressure any other value is there, then we have to change in our interface. Then we have to go to every other observer and make the change here as well in the method definition, right? So changes will be required in all the observers. So here we are passing data too frequently, right? So for example, if the change in temperature and humidity, pressure, like they happen too frequent, like then all the observers will be notified every time a small change happens, right? For example, if we want to notify our observers only if temperature is increased by or decreased by a degree Celsius, or pressure is changing by maybe 2 atmospheric pressure, that is not possible. Even a slight change will notify all our observers. So that is not possible with the current implementation of our pattern. So instead of push mechanism, we will let our observers pull their state, whatever state they require, we will let them pull it on their own. So I have taken example of Java 8 observable and observer class. So in this, they have a register observer, remove observer, and notify observers method, which practically work as we have seen above. And they have a set change method as well, and they have a polymorphic implementation of set of notify observer method. So in this, you can also pass any extra state that you want your observers to receive, like any other extra data that you want to pass to your observers, you can just pass it here. Set change method is used to indicate the subject that something has changed. So in this particular example, even if the measurement is changing frequently, like the temperature is fluctuating by 0.1 degree Celsius very frequently, the observers will be notified only when the set change is called and there is a variable called changed and it is set to true. So in our implementation, you will have a variable called for example boolean changed, and you will have a method called set changed, and whenever you set the change flag to true, then only your observers will be notified. So you can just put a condition here: if change equal to true, then go to this for loop, otherwise do nothing. So based on your conditions, like if the temperature is increasing by 1 degree Celsius, then only you make this change flag to true and call notify observers to notify all your observers. So this is used for that purpose. So we can also prefer composition for observable methods instead of inheritance, because it will provide you better flexibility and encapsulation. Also, it will allow you to test your code more easily. We will see a demo on this as well. So let's move to the demo part. I have created 3 versions of observer pattern. Let's look into them one by one. So the first version I have created is using the Java 8 observable and observer classes that is provided by the utils library of Java itself. So here our weather data, here it's our subject, and it extends the observable class that is provided by Java utils. So this class already implements these two methods, register and removing of observers, as well as notify observers. So as you can see, I have not implemented any of these methods here because it's not an interface, it's a class, and it has already implemented these behaviors. So the methods that I have here is only measurement change and set measurement and everything. That is only required for our class for changing the state and everything. So this notify observer, it will be calling the notify observer in this superclass. It's not this notify observer. It will be calling this that is already implemented in this class. Similarly, we have a display interface and all our display, weather statics display as well as current condition display. They implement both the observer as well as the display element interface. Again, this observer interface, it is coming from the Java utils. So we have implemented the display and we have overridden the update method that is provided by the observer interface. So in this, we are just setting up the temperature and humidity in current conditions, and then weather statistic display, we are just setting up temperature, humidity and pressure. So as you can see, there is no push mechanism. We are not receiving the updated value in the params, right? So if you will look the weather data here, whenever the measurement change, we are just notifying observer with some extra info. We are not passing this actual value. So this is the same argument I was talking about here, this extra argument in the parameters. So you can provide anything here, any string or object or anything you want, and we have these getters that our observers can use to get the updated value of this temperature, humidity and pressure. So let's say our client will call set measurement. It will update the temperature, it will set the new temperature, humidity and pressure here, and our observers will get notified that something has changed. Then our observers can get the updated value whatever they require from these getters, and they can update their display. So that is what is happening here. So let's look into the main and let me run it. Okay, so as you can see, we have created a new weather data object, and we are creating both the display objects and passing our weather data which is subject to it. So as soon as we create the object using this subject, these display, they register themselves to our observable. So they call this add observer method here. Let me go to this method, which is a Java utils method, and it will just add it to the list. Similarly, after that, when we call the set measurement on our weather data, which updates the new temperature, humidity and pressure, it will call the measurement change method, which will make the set change to true and notify all our observers. So as you can see, both the display statistic conditions as well as the current conditions, they are getting these new values on the pressure change, on the temperature change, 23 and 45 and 22 we are passing, right? So they are getting statistic display is getting all 3 of them, and current display is getting 2 of them, because current condition display is only pulling temperature as well as humidity, not the pressure. Okay, so let's show you one more thing. Let's comment this method call. So we are not setting the change flag to true. Let's try to run our main function again. So as you can see, this time, even if we are calling the set measurement function on our observable, which is here. As we are not setting the change flag to true, our observers are not getting notified, so you cannot see any output here, right? So because our flag is not true and our notify observer, the notify observer method that is already implemented in the observable class, it's something like this. If the changed value is set to true, then only our observers will got notified. Hence, as we are not setting the flag to true, our observers did not got notified. Okay, let's move to the next demo. So in this, instead of using the Java utils observable and observer class, I have created my own observable and observer. So here, instead of inheritance, I am using the composition here. So I have created an observable generic class here, which implements the basic methods like register observer, remove and notify observers. Here we just do a simple loop and simple addition and remover from the list. Now our weather data, which is our subject, it will just create a new object of this observable. It will just use composition instead of inheritance. It is using composition. So now it can have its own register remove and register and remove observer method, and it will just take it will just call the methods that are already provided by this observable object. So it can do its own calculations as well. Apart from that, it will just call these methods provided by the helper. It has all the getter methods that will be used by our observers to get the updated value, and all the other things are same. Measurement change and set measurement function, they are same. Similarly, we have an observer interface which will be implemented by our observers. So here we have current condition display and weather static display again, and we have a display element interface as well for the same purpose. So both all our display, they will implement the observer as well as the display element interface, and they will override both the methods update as well as display. So now while calling this observer as well as observable from our main class, we do something like this. Since we are not using inheritance, we create a new weather data, we create a display, and we can just call the weather data register observe from the client side itself. So from here itself, we can register all the observers. So the difference with the previous version is here, whenever we were creating the new observer objects and new displays, we were passing the subject in it, and the observer itself, while constructing the object, was calling the add observer method to register themselves to the subject. Here our main is doing that. So you can do anything you want, just a different way of implementing observer pattern. Both the ways are valid. So let's run it. So as you can see, I have registered both the displays as the observer, and whenever the measurement changed first time 23, 45 and 22, as you can see, both the displays they got the updated values. But I have removed the current condition display from the observer in the next line, and now when the measurement is changing, only the statistic display is getting the updated value. You don't see this log twice, right? Because we have removed the current condition display from the observers. Okay, let's quickly move to the demo 3. So here, as this observable and observer class provided by the utils library is deprecated after Java 8, they have provided something called flow, which uses this publisher subscription thing for the same purpose. So here I have created a news publisher. It just implements the publisher flow interface, and it's basically the same. We have a subscription here. It just takes a subscription from the flow subscription class from the flow, implements this interface, and override these two methods. Basically I'm doing nothing here. I just overriding these methods to make the code work. And similarly here in the subscribe, I'm just adding the subscribers to the list, and I'm just calling the onSubscribe method on the subscribers. So we'll look into the subscriber in a minute. Similarly, this publish news is getting called whenever we want any changes to be published to all the subscribers. So it will just call the onNext method on the subscriber. If you look into the subscriber, which is newsreader, it will just implementing the flow subscriber interface, and it overrides all these method on subscribe. Whenever it is it will be subscribing to a subscription, you can do something. And on next, like whenever any changes happens to the subscription, you will get these you will get the updated changes here. And on error and on complete, these are all the methods you can override and use for different purposes. Let's look into the main. So here we have created a new subject, new publisher, and we have created two subscribers for Alice and Bob, and we have subscribed both of them to the publisher. Now whenever a publisher is publishing a news, for example these two news, let's try to run it. So as you can see, these two news, breaking, observer, pattern and update news, they are listened by both Alice and Bob. So you can see both of them are getting these two news. But let's say after some time, Bob is unsubscribing to this news, right? And now when the publisher publishes a news, it will be received only by Alice. You can see this final news is not received by Bob, right? So this is same, just the way of implementation is different using flow library provided by the Java. Okay, that's all for the demo. Let's come back to our theory. So now where this observer pattern is applicable. So you have to use this observer pattern when the changes to the state of one object may require changing other objects, and the actual set of objects is unknown beforehand or changes dynamically. So in simple method, this can be used when other object needs to be notified on the changes of an object. For example, you have a weather data object. Whenever it changes, other objects of like display objects and other objects needs to be notified, right? In that case, you can use the observer pattern. You can use the pattern when some objects in your app must observe others, but only for a limited time or in specific cases. Now, when not to use the observer pattern. So they should not be mistaken for the event listeners we have out there, because here we have the tight coupling, right? So in the larger system, when the number of observers and subjects will be huge, then it will be very confusing to track who listens to what there, right? Because you have to go through code and you don't know who is subscribing to what. Like you have to go through the entire code to find out who is subscribing to what and how many observers publisher has. So this will be difficult if the number of subscribers and observers are huge. Plus they do not guarantee the order. So they can not this pattern. This will not guarantee you an order. For example, if you want your observers to receive notifications in some kind of order, this will not be possible in this case. So in this case, the event queues are better actually. So you can use any event queue like Kafka, RabbitMQ, Google Pub Server. There are many actually. You can use any of them when you need a guarantee of delivery. Of a message and you want some ordering in that as well. In the multi-threading context, it's not very thread safe actually. So observers may get inconsistent data, they may get stale data based on the thread and all. Race conditions could happen, deadlocks can happen. So for this purpose as well, when you are notifying a service on a change from other service, it's better to use event queues there again. You should not make implementations like this. So it also does not guarantee persistence. For example, let's say there are two microservices. One of the microservices is a publisher and another is subscribing to that. So if the subscription goes down for a time period, whatever update that came the publisher published, they will not be received by this receiver when it comes back up, because your message data will get lost. This pattern does not persist any message, right? Here again, event queues will be more helpful because they can persist the messages up to a certain specific period of time. You can configure that as well. So based on your configuration, they can persist the messages for a certain amount of time, and whenever a subscriber comes back up, it can start from where it left actually. So persistence and guaranteed delivery is provided by the message queues. This pattern you can use on a low level design. For example, in your UI, maybe you separate your view from the controller, from the view controllers, you separate out your models from the view controller, and whenever you get the new data using the REST APIs, you want your view controllers to get updated, right? You can use this there. So if you have worked on the React and Redux, you might have seen whenever the Redux state gets updated, your views get updated, right? You get the updated state in the different um, components. So you subscribe to a particular state in the Redux, and whenever that particular state gets updated, that component also gets rendered, right? So there it can be used, because there you want this tight coupling, and it's in the single application, right? So it's not possible that publisher will be up and subscriber will be going down. So on these kinds of scenarios, you can use these pattern, but not in the microservice architecture, because it's not very fault tolerance, and it does not guarantee any delivery of the message as well as persistence. uh, okay, I hope this was clear to you. Thank you, and I will see you in the next video. Please like, share and subscribe.